Picture this, a planet almost identical to Earth in size and density, yet scorchingly hot, with rivers of lava and a sky filled with sulfuric acid clouds. Welcome to Venus, often dubbed as Earth's evil twin. As the second planet from the Sun, Venus shares more than just proximity with Earth. Both planets are roughly the same size and they're made of similar stuff, primarily rock. But that's where the similarities end. While Earth is a haven of life with a moderate climate and a rich diversity of ecosystems, Venus is a veritable inferno with surface temperatures hot enough to melt lead. Imagine a world where the sky is perpetually shrouded in dense yellowish clouds of sulfuric acid, where the air pressure at ground level is 92 times that of Earth, equivalent to being 1 kilometer underwater. A world where the light from the sun never fully penetrates the cloud cover, casting a perpetual twilight across its barren, rocky landscape. This is Venus, our neighboring planet. But it wasn't always this way. Scientists believe that Venus may have once been more Earth-like, with a milder climate and possibly even oceans of liquid water. So what happened? How did Venus transform from a potential cradle of life into a blistering hellscape? The answer lies in Venus's atmosphere. Unlike Earth, which has a relatively thin atmosphere, Venus has a thick blanket of mostly carbon dioxide, with clouds composed of sulfuric acid. This dense atmosphere creates a runaway greenhouse effect, trapping the sun's heat and causing surface temperatures to soar to an average of 467 degrees Celsius. That's hotter than the surface of Mercury, the planet closest to the sun. Despite its similarities to our home planet, Venus presents a starkly different, hostile environment. The question is, why did Venus, our planetary sibling, turn into this hellish world? Venus wasn't always a fiery hellscape. There was a time when it might have been more like Earth, possibly even with liquid water. Imagine a Venus of the past, not too dissimilar to our own blue planet. But over time, a series of events unfolded that would drastically alter the course of Venus's history, transforming it into the hottest planet in our solar system. You might be wondering, how did this dramatic transformation occur? The answer lies in the concept of a runaway greenhouse effect, a phenomenon where the accumulation of greenhouse gases in a planet's atmosphere traps heat, causing the planet's temperature to soar. This process is like a vicious cycle. The hotter it gets, the more greenhouse gases are released, trapping more heat and so on. For Venus, this runaway effect was unstoppable, leading to surface temperatures hot enough to melt lead. But here's the real kicker. Venus might have once had water, much like Earth. Yes, you heard that right. This scorching planet could have once been home to vast oceans. But if that's the case, what happened to all the water? The answer is quite fascinating. Scientists believe a molecule called HCO+ played a crucial role in this. This molecule was key in breaking down water in Venus's atmosphere into its constituent elements, hydrogen and oxygen. The lighter hydrogen then escaped into space, leaving behind a dry, desolate planet. Now, you might be thinking, Venus is in the Goldilocks zone of the sun, just like Earth, so why didn't it retain its water? Well, that's a mystery that scientists are still trying to unravel. Future space missions, like NASA's Da Vinci, aim to explore Venus further and potentially confirm the presence of HCO+ in its atmosphere. The transformation of Venus from a potentially habitable planet to a blistering inferno is a catastrophic example of a runaway greenhouse effect. This transformation serves as a stark reminder of the delicate balance that keeps our own planet habitable and the catastrophic consequences if that balance is disrupted. The atmosphere of Venus is a thick, toxic blanket, primarily composed of carbon dioxide with clouds of sulfuric acid. This description paints a rather grim picture, but it's an accurate one. You see, the atmosphere of Venus is no ordinary celestial shroud. It's a deadly cocktail that contributes significantly to the planet's extreme conditions. Imagine an overcoat not made of wool or down, but of carbon dioxide, 96% to be precise. This isn't your everyday greenhouse gas scenario, it's an extreme version, a runaway greenhouse effect, if you will. This dense layer of carbon dioxide traps heat from the sun, causing surface temperatures to skyrocket to an astounding 867 degrees Fahrenheit. That's hotter than the surface of Mercury, even though Venus is nearly twice as far from the sun. But the story doesn't end there. Suspended in this carbon dioxide overcoat are thick, oppressive clouds of sulfuric acid. Picture a smoggy day in a bustling city, then amplify that image 100-fold. These clouds perpetually shroud the planet, making sunlight a rare commodity on the Venusian surface. The implications of this, you ask? Well, the sulfuric acid clouds not only block sunlight but also create a sort of acid rain. However, this rain never reaches the surface. Instead, the extreme heat causes it to evaporate, creating a constant cycle of acid rain formation and evaporation. This acidic environment and intense heat make Venus a rather unwelcoming place. Any water that may have existed on the planet's surface would have evaporated long ago due to these harsh conditions. And with water being a critical ingredient for life as we know it, the chances of finding life on Venus are, to put it mildly, slim. So, when we peel back the layers of Venus's atmosphere, what we find is a world far removed from the serene beauty of our own. A world where day is perpetual twilight, where rain evaporates before it hits the ground, and where the air one breathes is a deadly mix of carbon dioxide and sulfuric acid. The dense, suffocating atmosphere of Venus plays a significant role in its inhospitable conditions. Indeed, while Venus may be Earth's twin in size and density, it's a mirror image that has been twisted and distorted into something far more sinister. The greenhouse effect, a natural process, has turned deadly on Venus. You see, the greenhouse effect is a necessary phenomenon that makes Earth habitable. It's the process where certain gases in a planet's atmosphere trap heat, preventing it from escaping into space. These gases, aptly named greenhouse gases, include carbon dioxide, water vapor, and methane. On Earth, they serve as a thermal blanket, keeping our planet warm enough to support life. A delicate balance exists, however, and when the concentration of greenhouse gases increases, so does the trapped heat, leading to global warming. Now let's turn our gaze back to Venus. This planet took the greenhouse effect to an extreme. Venus's atmosphere is predominantly composed of carbon dioxide, a potent greenhouse gas. This thick layer of carbon dioxide traps and stores heat from the sun much more efficiently than Earth's atmosphere does, but that's not the end of the story. Venus's surface temperature is further amplified by its dense clouds of sulfuric acid. These clouds reflect sunlight, which combined with the greenhouse effect creates a vicious cycle. The more heat that's trapped, the hotter Venus becomes, and the hotter it becomes, the more heat is trapped. This is known as a runaway greenhouse effect, and it has transformed Venus into the sweltering world we know today, with temperatures reaching up to 867 degrees Fahrenheit. The situation on Venus serves as a stark reminder of the power and potential danger of the greenhouse effect when it spirals out of control, running unchecked and unbalanced. What was once perhaps a more Earth-like world has been transformed into a scorching, inhospitable planet due to an overzealous greenhouse effect. The greenhouse effect, while vital for life on Earth, has run amok on Venus, turning it into a scorching, lifeless world. Our journey to Venus, Earth's evil twin, ends here, but the exploration of the universe never stops. We've journeyed through the hostile landscapes, peered into its thick sulfuric acid clouds, and delved deep into the mysteries of its atmosphere. But this is just one planet, one story in the grand cosmic tapestry that is our universe. There are countless more celestial bodies to explore, numerous mysteries to unravel, and endless knowledge to gain. And we want you to be a part of this cosmic expedition. We invite you to share your thoughts, your ideas, your theories about Venus and its transformation. How do you think Venus evolved from an Earth-like planet to the scorching, waterless world it is today? What role do you think the molecule HCO+ played in this dramatic transformation? We'd love to hear your insights. If you've enjoyed this voyage to Venus and are eager for more, we encourage you to subscribe to our channel. We have a myriad of space content lined up for you, from the mysteries of black holes to the wonders of far-off galaxies. Subscribing to our channel allows you to join us on these exciting cosmic adventures, and it also supports us in creating more engaging and informative content for all space enthusiasts out there. If you found this video enlightening, give us a thumbs up. Every like boosts our reach, allowing more space enthusiasts to join us in our quest to understand the universe. Your support helps us continue our mission of making the wonders of space accessible to everyone. Remember, every like, share, and subscription takes us one step further in our cosmic journey. Until next time, keep looking up and wonder about the mysteries of the universe.